Hi, AP Bio. A quick note on functional groups and bonds that we are going to be looking at. Oftentimes, this term functional group gets either overlooked or people tend to think it's a lot harder than it really is. So, all that we're talking about when you hear the word functional group is just a category or something that's going to have its own behavior. So, when we look at the structure of a molecule, the structure is going to tell us its behavior. And there's a lot of chemistry reasons behind that, but we as biologists just like to simplify that and say, great, okay, these molecules that have these groupings or these bonds are going to behave in a certain way. So when we look at those, we can see them clumped together. And so you have different types that tend to show up. Of course, Remy's giving his 2 cents in, but we can ignore him. But this picture on the left-hand side, if we've already watched the organic or biomolecule one, here's the phosphate group. So phosphate groups just tend to show up a lot as we go through things. It doesn't mean anything. It's just that I, as a biologist, might notice phosphate groups a lot. So in places like DNA has sugar phosphate base. ATP is adenosine triphosphate. We tend to see them a lot showing up. So it's a functional group. The one above the phosphate group, the sulfhydryl group, actually tends to make proteins want to make curves in them or corners and fold on themselves. And so they just have these specific types of behaviors. The top one, hydroxyl or OH, that should seem familiar as you're going through if you remember chemistry. Some of these, the amino group, we tend to see with proteins as we go through things. So, types of things that we're going to break down and not break down. So in order for a molecule to bond, we tend to see what's called a dehydration reaction. Basically, dehydration, lose water. So we're going to form a chemical bond, we're going to lose water. Okay, so I have two molecules come together, they're going to form a bond, we take out H2O. Now, the opposite of a dehydration reaction is just going to be hydrolysis. So hydrolysis, lyse, we're breaking down. So we're going to add in water. Lyse means to break down. We're going to use that water to break down the molecule. We're going to add in water and break down our molecule into two smaller molecules. Quick introduction. We'll come back to this again later.